Today we are going to be identifying graphs of exponential functions. But first, you see that we have a do now 1 through 4. The do now does look a little bit confusing, but it is actually something you already know how to do. So I will do number 1 with you. So if we take a look, we have 1/3, that dot means times, 6 to the x power at x equals 2. All that means is that when since x equals 2, we are going to substitute in 2 for x. So let's take a look. 1/3 times 6 to the second power. So we're going to put that into our calculator. So we're going to hit alpha y equals enter. Put in our 1/3 times 6 caret. Right, the caret is above the division sign on the calculator, 2. And we end up with 12. So that's all you would be doing for 1 through 4. So let's take a look at different types of functions. So we have linear functions, quadratic functions, and exponential functions. Let's talk about the graphs of each. So a linear function we know is just a line. That is because the word line is in linear. So next we have a quadratic function. We know a quadratic function is a parabola, which we talked about. So it's a curve. It can also go down as well. It can also be a curve like this. So we call that a smiley face or a sad face if you want to call it that. And the third one we see is an exponential function. Now, an exponential function is not something you have seen. It is relatively new to you, but nothing too difficult. So what an exponential function is it's always going to start near the x-axis, and it's going to shoot up really fast. So it's not a straight line. It doesn't go down then up like the quadratic function. It starts really low, and then it will shoot up really high. You might also see something that looks like this. So here's my xy axes. And an exponential function might start at the x-axis and shoot down. It's important to know that the exponential function never crosses the x-axis. It will come close to it, but it won't actually touch or cross. Now let's take a look at the general equation of each function. So if we take a look at a line, we know the equation of a line is y equals mx plus b. So for example, it could be y equals 3x plus 5. A parabola, we know it's whenever you see an x squared. Whenever you see that x squared, that's a hint that it's going to be a quadratic function. So for example, we could have y equals x squared plus 2x minus 1. That would be an example there. Remember, whenever you see an x squared, it's always going to be a quadratic function. And an exponential function. Y equals ab to the x power. Really, all that would mean is, let's say y equals 1/3 times 6 to the x power. So that's what the do now was. So look, we have it's being raised to the x power. So that's really your hint that it's an exponential function. Whenever you see the x as the exponent, that's going to be your clue that that is the exponential function. So let's take a look at when we're given a table. Now you might be given a table and they might say, what kind of function is this? So again, linear function, quadratic function, and exponential function. Let's first talk about the linear function. So this looks like when you're given a table in the calculator. That's really what this is. How to figure out if I had this table, is it linear, quadratic, or exponential? Well, when we have a linear function, we say how do we go from -2 to -1? We just added 1. How do we go from -1 to 0? We added 1. How do we go from 0 to 1? Same thing, we added 1. And how do we go from 1 to 2? We just added 1. You do the same thing with the y's. So with the y's, how did I go from 1 to 3? I just added 2. How did I go from 3 to 5? Added 2. 5 to 7, we add 2. And 7 to 9, we added 2. So we see that they have something in common, right? The x's go up by 1s consistently, the y's go up by 2s consistently. So we know it's a linear function when we have a first common difference. So all that means is, does it consistently go up by the same number each time? So we call that the first common difference. So let's take a look at quadratics. So now, a quadratic function, again, I'm given this table, and I go to my x's, I say, how did I go from -2 to -1? I add 1. How do I go from -1 to 0? I add 1. And same thing you see throughout. We're just adding 1 all the way through on the x's. So okay, that's good. That's like what we've done with the linear function. So let's take a look at the y's now. How did I go from -1 to -2? Well, I subtracted 1. How did I go from -2 to -1? Well, I added 1. How did I go from -1 to 2? I added 3. And how did I go from 2 to 7? Well, 2, 3, 4, 5, 6, 7, you add 5. Now, if you notice, these are not consistent. So that's how we know it's not a linear function. But we have to do a little bit more investigating. We have to say, well, okay, can it be a quadratic function? So in order to find out if it is a quadratic function, what you're going to do, you're just going to do the same thing with these numbers here that we just found. So we're going to say, okay, how do we go from -1 to 1? We add 2. How do we go from 1 to 3? We added 2. How do we go from 3 to 5? We added 2. So what do you notice about these now? Now those are going up consistently. So what we call that is it has a second common difference. So in order to be quadratic, you would have to do that twice to see. So let's take a look now at the exponential function. So again, look, we have our exponent is our x here. So that's how we know it's exponential. So if we look at our x's, we first, again, how do we go up? We're going up by 1s. But the y's is really what's going to be important here. So if you notice, how do I go from 1 to 2, 2 to 4, 4 to 8, 8 to 16? Do you notice that it's going up really fast? I see it's going up really fast. Look at this. We already went from 1 to 16 just from -2 to 2. That right there should be a hint to you that that is exponential. Whereas if we take a look at the linear function, it's not really going up really, really fast. It's just going up, little by little. Here, we're not going up little by little because look, we went from 8 to 16. So in exponential function, we're actually multiplying. So if you notice, how do I go from 1 to 2? I multiply by 2. How do I go from 2 to 4? I multiplied by 2. 4 to 8, I multiplied by 2. And 8 to 16, I multiplied by 2. Now, you might say to yourself, well, what if I didn't see that at first? That it was getting really big really fast? That's okay. Let's pretend like we didn't see that. So, like this. Okay, so if we pretend that we said, okay, I really don't know which one this is by just looking at it. Let's check to see if it's a linear function, right? So we'll pretend like that's not here. All right. So you'll say, okay, if I'm pretending this is a linear function, I would say, how did I go from 1 to 2? I added 1. How did I go from 2 to 4? I added 2. How did I go from 4 to 8? I added 4. How did I go from 8 to 16? I added 8. Well, you could see that there's no first common difference there because it doesn't go up the same throughout. So you would say, okay, so what if it's quadratic? Let me see if there's a second common difference. So I say, okay, how did I go from 1 to 2? I added 1. How did I go from 2 to 4? I added 2. How did I go from 4 to 8? I added 4. So there's no first common difference. And there's no second common difference. So that's when you would say, okay, let's see if it's exponential. So that's when we would say, all right, well, am I multiplying by something? Since there's no first common difference and there's no second common difference. And that's when you would say, okay, 1 to 2, I multiply by 2, 2 to 4, multiply by 2, and so on and so forth. So if you take a look here, it says, does each table represent a linear, quadratic, or exponential function? So what you would have to do is you would have to see if there's a first common difference, if there's a second common difference, is it going up really fast? So your explanations would be, we have to write the explanation for this. So this would be has a common, we call this a common ratio. All right, so if we take a look, our 3 reasons are here. It's a linear function if it has a first common difference. It's a quadratic function if it has a second common difference. And it's an exponential function if it has a common ratio. There should be no n there. All right, so you might say to yourself, okay, well, I know if I go from 0 to 1, I'm subtracting 1. 1 to negative 2, I'm subtracting 1. All right, so this one you might be able to see. But now, you might say, well, how did I go from 48 to 55? Well, we know we're going up. We know we're adding. So if we actually took this number here and subtracted the one above it, we would be able to see how much we're going up by. So if I did 55 minus 48 in my calculator, I would end up with 7. So I know I'm going up by 7. So you might say, well, how did I go from 55 to 69? So you know you're going up. If you take the bottom number underneath it and subtract the top number, we'll figure it out. So 69 minus 55, we get 14. Okay. How did I go from 69 to 90? Same thing. You know you're going up. Just do the bottom number minus the top number. 90 minus 69. And you would end up with 21. And how do we go from 90 to 118? You would do 118 minus 90. And we'd end up with 28. So you see here, we don't have a first common difference, so it can't be linear. So now let's see, is there a second common difference? So 7 to 14, we added 7. And if you didn't know that, you could do 14 minus 7. How did I go from 14 to 21? I'm adding 7. How did I go from 21 to 28? I'm adding 7. So it would be a quadratic because it has a second common difference. So that's all we're going to be doing today. You're just going to be determining, is it linear, is it quadratic, or is it an exponential function?